Hello everyone, welcome to my channel. Today I am going to teach you integers, properties of integers ICSE 7th grade. Properties of multiplication of integers. First property is closure property. What is closure property? The multiplication of two integers is always an integer. 1 minute. Okay. Always an integer. For example, that is, if m and n are integers, then the product of m and n is also an integer. That is, mn is also an integer. Example is 5 is an integer. 6 is an integer. Then their multiplication 5 into 6 is equal to 30. 30 is also an integer. Then minus 15 and 6 are integers. Minus 15 is a negative integer and 6 is a positive integer. Negative into positive is equal to negative. So minus 15 into 6 is equal to minus 90. 90 is also an integer. So the closure property is true for the multiplication of integers. The multiplication of two integers, the product of two integers is also an integer. That is 5 is 5 is an integer, 6 is an integer. Then product of 5 and 6 is equal to 30. 30 is also an integer. This is true. Then next property is commutative property. That is commutativity. What is commutativity? According to this property, if m and n are two integers, then m into n is equal to n into m. That means first m into n, first multiply m multiplied by n, then we'll get the answer is same as first n multiplied by m. For example, see, m is equal to 6 and n is equal to 7. 6 into 7 is equal to 42. The same answer is 7 into 6, that is equal to 42. So this is true. That is m into n is equal to n into m. And one more example is minus 10 into 8 is equal to minus 80. 8 into minus 10 is equal to minus 80. Minus 15 into minus 77 is equal to 105. Then minus 7 into minus 15 is equal to 105. So the commutativity property is also true for the multiplication of the integers. Next is associative property. That is associativity. What is associativity? According to this property, if m, l, m and n are three integers, then l into m into n is equal to l into m into n. That means first multiplied by m into n, then the product of m into n multiplied by l. That is same as first multiplied by l into m, the product of l into m into n. Both answers are same. Let me check. For example, L is equal to 5, M is equal to 3 and N is equal to 2. So first multiplied by 3 into 2. 3 into 2 is equal to 6. Then 6 into L, that is 5. 5 into 6 is equal to 30. Then L into M. First L and M are multiplied by product of 5 L into M, that is 5 into 3, that is equal to 50 into N, that is 2, that is equal to 30. So both answers are same. The next one is minus 5, 3 and 2. Minus 5 into 3 into 2, which is equal to minus 5 into 6, that is equal to minus 30. That is minus 5 into 3 into 2 is equal to minus 30. Both answers are same. So the associative property is also true. The next one is distributive property, that is distributivity. Then what is this? According to this property, if L, M and N are three integers, then L into M plus N, that is sum of M plus N multiplied by L equal to multiplied by each L into M plus product of L into M plus product of L into N. That is multiplication is distributive over addition. Example. L is equal to 5 and M is equal to 7 and N is equal to 2. So L into M plus N, that is equal to 5 into M plus N means 7 plus 2, that is equal to 9. So 5 into 9 is equal to 45. Then next is L into M, that is L means 5. 5 into M, that is 7. 5 into 7 plus L into N, that is 5 into 2, that is 35 plus 40, that is equal to 35 plus 10, sorry, 35 plus 10, which is equal to 45. Both answers are same. Therefore, L into M plus N is equal to L into M plus L into N. One more example is minus 6 and minus 50 and 8. L into M plus N, which is equal to minus 6 into minus 15 plus 8, which is equal to minus 6 into minus 7, that is equal to 42, because two negative integers multiplied by product of two negative integers, then we'll get a positive, that is negative into negative is equal to 42. Then next is L into M plus L into N. Minus 6 into minus 15 plus minus 6 into 8, that is equal to 90 minus 48, that is equal to 42. So both answers are same. Therefore, L into M plus N equal to L into M plus L into N. Both answers are same. So, the multiplication distributive over addition is true. Next is distributivity of multiplication over addition can also be stated as L plus M into N is equal to L into N plus M into N. Distributive of multiplication over subtraction is also true. That means distribution of multiplication over addition is also stated as this is true. Then next is distributivity of multiplication over subtraction is also true. Let me check. L into M minus N. Last we will discuss multiplication over addition. Next is multiplication over subtraction. Let me check. L into M minus N, which is equal to L into M minus L into N, and L minus M into N, that is equal to L into N minus M into N. Example, if L is equal to 8, M is equal to minus 30, 30 and N is equal to 7, then L into M minus N is equal to, L is equal to 8, 8 into 13 minus 7, that is 8 into 6, that is equal to 48. Then L into M minus L into N, that is L means 8, 8 into 13 minus 8 into 7, that is equal to 104 minus 56, which is equal to 48. Both answers are same. Therefore, L minus M into N is equal to L into N minus M into N. That means distributivity of multiplication over subtraction is also true. Existence of multiplicative identity. For every integer a, we have a into 1 is equal to 1. A into 1 is equal to a and 1 into a is equal to a. That is a into 1 is equal to 1 into a is equal to a. Since the multiplication of every integer a with integer 1 gives the integer a itself. That means integer 1 is called the multiplicative identity. For example, 5 into 1 equal to 5 into 5 and 1 into 5 is equal to 5. That is multiplication of every integer multiplied with integer a with the integer 1. For example, multiplication of integer 2 into 1 is equal to 1, 2 into 1 is equal to 2, and 3 into 1 is equal to 3. That is integer 1 is called the multiplicative identity. Every multiplication of every integer a with the integer 1 gives the integer a. That is, this means that 1 is the multiplicative identity. Next is existence of multiplicative inverse. For any integer a, its multiplicative inverse will be 1 by a. So that a into 1 by a, which is equal to 1. That is a into 1 by a cancel, then which is equal to 1. The multiplicative identity. Thus, the multiplicative inverse of an integer exists if integer x its multiplicative inverse is 1. The multiplicative identity out of integers. Multiplicative inverse of 1 is 1 itself. That is 1 into 1 by 1. 1 by 1 is equal to 1. So multiplicative inverse of 1 itself as 1 into 1. 1 into 1 by 1, which is equal to 1. And multiplicative inverse of minus 1 is minus 1 itself. That is minus 1 into 1 by minus 1. Then negative into negative, positive. So which is equal to 1. That is multiplicative inverse of minus 1 is minus 1. The product of odd number of negative integer is always negative. Minus a1 into minus a2 into minus a3 into etc. up to an odd number of negative integers, which is equal to minus a1, a2, a3 etc. which is equal to a negative integer. The example is minus 2 into minus 3 into minus 4, which is equal to, we are adding 3 numbers. The 3 is an odd number. Then minus 2 2 into minus 3, that is negative into negative is equal to positive. Positive into negative is equal to negative. So the product should be negative, that is which is equal to minus 24. That is product of 3 negative integers is negative. Product of 3 negative integers, which is negative. That means 3 is the odd number. That is the product of odd number of negative integers is always negative. The product of number of negative in even number of negative integers is always positive. See, minus a1 into minus a2 into minus a3 into minus a4 up to an even number of negative integers, which is equal to minus a1, a2 into a3 into etc. which is equal to a positive integer. That is, for example, minus 2 into minus 3, which is equal to 6. That is, this is the product of two integers. 2 means even number. That is minus into minus positive. So, which is the answer is positive. Product of two negative integers is positive. Thank you. Please don't forget to like, share and subscribe.